700 million years after the moment of creation, in an epoch when the universe was still a newborn, something impossible lurked in the darkness. Humanity, in its relentless quest to understand its origins, had built a magnificent eye. The James Webb Space Telescope, the most powerful observatory ever conceived, was designed to peer back into the deepest, earliest moments of time. Its gaze was aimed at the cosmic dawn, searching for the first flickers of light from the very first stars and galaxies to ignite in the primordial blackness. Unfolding its golden mirrors in the cold vacuum of space, a million miles from Earth, it began to collect the faint, fossilized light from this bygone era. The images it sent back were breathtaking. A tapestry of cosmic wonders, more intricate and vast than we had ever seen. Each smudge, each spiral, each point of light was a galaxy, home to billions of stars and perhaps countless worlds, their light stretched and reddened by the expansion of the universe itself. Amid this celestial ocean, teeming with billions of similar objects scattered across the cosmic web, the telescope detected a tiny red dot. It was unremarkable, just another faint speck floating in the ancient darkness. Scientists initially dismissed it as such, another distant galaxy in its infancy, nothing special among the countless others. In the grand business of cataloguing the cosmos, it is easy to overlook the mundane. The universe is filled with red dots, their colour a testament to their immense distance, their light having travelled for so long that the expansion of space has stretched its waves, shifting them towards the red end of the spectrum. This dot was catalogued, noted, and almost forgotten, a single data point in a flood of information. But science is a discipline of suspicion, of second glances. When astronomers finally aimed their more sensitive instruments directly at this particular crimson speck, they were not prepared for what they would find. As they analyzed the light, breaking it down into its constituent frequencies, they discovered something that made their blood run cold. The dot was not behaving like a normal galaxy at all. Its light signature was strange, haunted. It contained mysterious broad hydrogen lines, a spectral fingerprint that could mean only one thing. Something inside that dot was moving with violence, at incredible, impossible speeds. Gas clouds, vast streamers of primordial matter, were spinning so fast that they should have been torn apart by centrifugal force, flung out into the void. According to the known laws of physics, no cohesive structure could withstand such rotational velocity. Yet somehow, these clouds remained intact, held together by a gravitational force of unimaginable power. This was not just a theory. It was confirmed through meticulous, spectroscopic analysis, revealing rotation velocities that reached thousands of miles per second. No ordinary collection of stars, no nascent galaxy could generate such extreme motion without destroying itself completely. Something else had to be there. Something unseen, something impossibly massive and dense, lurking at the heart of the red dot and holding it all together. The Discovery team, led by researchers at Cambridge University, realized they were witnessing something wholly unprecedented in the annals of cosmic history. The calculations were checked, the data reanalyzed, but the conclusion remained terrifyingly consistent. The only explanation for the gravitational pull required to bind those furiously spinning gas clouds was an object with a mass equivalent to 50 million of our suns. 50 million stars, crushed into a region of space so small it defies comprehension, creating a gravitational well so deep that light itself could barely escape its clutches. For comparison, the supermassive black hole at the center of our own Milky Way galaxy, Sagittarius A star, a behemoth that took more than 13 billion years to reach its current size, weighs a mere 4 million solar masses. This newfound object was more than 12 times larger, a true monster of the deep. But what makes this discovery truly terrifying is not just its incomprehensible mass, but its location in space-time. We are seeing this object exactly as it appeared when the universe was barely 5% of its current age. The light from this red dot began its journey just 700 million years after the Big Bang. This period, known as the era of reionization, was the universe's own genesis, the moment when the first stars had just begun to ignite, their radiation pushing back the cosmic darkness that had reigned for hundreds of millions of years. It was a time of cosmic infancy. The universe was still forming its fundamental structures, still assembling its first stellar nurseries and protogalaxies. According to every theoretical model of cosmic evolution, the universe at this stage was simply too young, too undeveloped, to have created such a monster. The prevailing wisdom, built upon decades of observation and simulation, described a gradual, hierarchical process. Small things formed first. The first stars, massive and violent, would burn out and collapse into small black holes, perhaps 10 or 100 times the mass of our Sunday. Over eons, these smaller black holes would merge, and slowly, painstakingly, they would consume the gas and stars of their host galaxies, growing larger over billions and billions of years. The process was meant to be slow, a cosmic marathon, not a sprint. Time was the essential ingredient, and in the early universe there simply had not been enough of it. Yet here, in this single red dot, was definitive proof of a monster hiding in plain sight. A creature that had seemingly skipped the entire process of gradual evolution. It was not a gradual formation built up over eons. It was a primordial titan, born almost fully formed in the cosmic dawn. The implications sent shockwaves through the astronomical community. If a black hole of 50 million solar masses could exist when the universe was practically newborn, then everything we believed about how cosmic structures form, how galaxies evolve, and how black holes grow needed immediate and radical revision. It was as if we had been meticulously documenting the growth of forests, only to discover a fully mature 1,000-year-old sequoia in a photograph taken the day after the world began. The mystery deepened when the team examined the monster's surroundings. The analysis revealed that this colossal black hole was essentially naked, existing without the vast, sprawling galaxy that should surround such a massive object. In the modern universe, supermassive black holes are always found at the centers of large galaxies, a gravitational anchor surrounded by the billions of stars that feed them and grow with them over cosmic time. The galaxy and its central black hole are partners in a cosmic dance that has continued for over 13 billion years. But this object had no partner. It floated alone in the cosmic void like a solitary predator stalking empty space. The environment was chemically pristine, a raw, unprocessed soup of hydrogen and helium left over from the Big Bang, indicating that very few stars had ever lived and died there. So the questions multiplied, each more profound than the last. How could such a massive black hole form so quickly in a universe that had just begun? And how could it exist without a corresponding galaxy to feed it? It was a cosmic aberration, a ghost in the machine of creation. It was not just an object that was difficult to explain. It was an object that the laws of physics, as we understood them, declared to be impossible. The single red dot had become a cosmic crisis. It was no longer just a discovery. It was a verdict, a judgment delivered across 13 billion years. But our story of the universe was missing its first and perhaps most important chapter. The chapter of the monsters that came before everything else. The existence of such an object, a titan born in the wrong cosmic era, presents a paradox so profound it seems to border on the supernatural. It is a ghost from a time we can barely comprehend, and its discovery feels less like an act of astronomy and more like an act of cosmic archaeology, an unearthing of a relic that rewrites our entire history. But this was not magic, nor was it an accident. The ability to witness this impossibility was not a matter of chance. It was the result of one of the most ambitious and daring scientific endeavors ever undertaken by humankind. To find a ghost, we first had to build a machine capable of seeing them. We had to construct a time machine. For decades, our window into the deep universe had been the magnificent Hubble Space Telescope. It revolutionized our view of the cosmos, showing us galaxies in stunning detail and revealing a universe more vibrant and crowded than we had ever imagined. But Hubble, for all its power, had a fundamental limitation. It sees the universe primarily in visible and ultraviolet light, the same kind of light our own eyes perceive. While this is perfect for observing the relatively nearby cosmos, the truly ancient universe remains shrouded from its view. The very first galaxies, the very first stars, the very first monsters like the one at the heart of the red dot, are broadcasting a message that Hubble was never designed to receive. Their light, after traveling for more than 13 billion years through an expanding universe, has been altered, its signature transformed into a language that only a new kind of eye could ever hope to decipher. To understand how this is possible, we must first grasp a fundamental truth about the universe. Looking out into the vastness of space is, by its very nature, looking back into the past. This is not a complex theoretical notion, but a simple consequence of the finite speed of light. Light, though the fastest thing in the universe, still takes time to travel. The light from our own sun takes more than 8 minutes to reach Earth, meaning we always see the sun as it was 8 minutes ago. The light from the nearest major galaxy, Andromeda, takes 2.5 million years to cross the interstellar void. When we look at Andromeda through a telescope, we are seeing it as it was when early human ancestors were first walking the Earth. The object at the heart of the red dot is vastly more distant, its light having begun its journey towards us when the universe itself was a mere 700 million years old. We are seeing a snapshot of a cosmic infant, an image delivered to us 13 billion years late. But distance is only half of the story. The journey of that ancient light is not a simple transit through empty space. It is a journey through a universe that has been constantly expanding since the moment of the Big Bang. This expansion has a profound effect on the light itself. It can be visualized as a wave drawn on the surface of a balloon. As the balloon is inflated, the wave itself is stretched out, its wavelength becoming longer. The same thing happens to light traveling through expanding space. Light that may have started its journey as high-energy ultraviolet or visible blue light from the first brilliant, massive stars gets stretched as it crosses the expanding cosmos. Over billions of years, its wavelength is elongated, shifting it down through the colors of the rainbow, past red, and into a form of light that is entirely invisible to the human eye, infrared light. This phenomenon is known as cosmological redshift, and it is the single greatest challenge and the single greatest opportunity in the study of the early universe. It means the ancient cosmos is an infrared cosmos. To see it, we could no longer rely on eyes that see in the visible spectrum. We needed to build an infrared eye. This was the driving purpose behind the James Webb Space Telescope, a machine conceived to conquer the challenge of redshift and open a window into this hidden, primordial era. It is an instrument of exquisite sensitivity and staggering complexity, a marvel of engineering that pushes the very limits of what is possible. Its heart is a mirror unlike any other ever constructed. It is a colossal golden eye, 6.5 meters in diameter, so large that no rocket could carry it in one piece. Instead, it was designed as a work of origami, composed of 18 perfectly hexagonal segments that would fold up for launch and then unfurl in the cold of space. These segments are crafted from beryllium, a metal both incredibly strong and exceptionally lightweight, polished to a smoothness so precise that its imperfections are measured in atoms. And over this perfect surface, a microscopically thin layer of pure gold was applied. Gold was not chosen for its beauty, but for its physics. It is one of the most highly reflective materials in the universe for infrared light, the very light that the telescope was built to see. This golden mirror would be our collector, our net, gathering the faintest, oldest photons in the universe. But to see in the infrared, it is not enough to simply have a large mirror. The telescope itself must be almost unimaginably cold. Any object with a temperature above absolute zero emits its own infrared radiation, its own heat. If the James Webb Space Telescope were to operate at even room temperature, its own glow would be a blinding fog, completely overwhelming the faint signals from the dawn of time. It would be like trying to photograph a distant firefly while standing in the middle of a spotlight. The telescope had to be shielded from any source of warmth, most notably from our own sun, the Earth, and even the Moon. The solution was one of the most audacious pieces of engineering ever deployed in space: a sunshield the size of a tennis court. This sunshield is not a single sheet, but a delicate, 5-layered kite of a material called kapton, each layer thinner than a human hair and coated in aluminum and silicon. These layers were designed to be deployed in space, separating from one another with a vacuum gap between each. This design acts as a cosmic refrigerator. The first layer blocks the vast majority of the sun's heat, reflecting it back into space. The small amount of heat that gets through is then reflected by the second layer, and so on, 5 times over. The vacuum between the layers is a perfect insulator, preventing heat from conducting through the shield. This intricate system allows the side of the telescope facing the sun to be hot enough to boil water, while the side in shadow, where the golden mirror and sensitive instruments reside, is passively cooled to a staggering 230 degrees Celsius below zero, just a few tens of degrees above absolute zero, the theoretical point at which all atomic motion ceases. In this profound cold, the telescope's own infrared glow is silenced, allowing it to listen for the whispers of the early universe. The creation of such a machine was a multi-generational effort, involving thousands of scientists and engineers from around the world, a testament to decades of human ingenuity and persistence. But building it on Earth was only the first challenge. The second was delivering it to its destination and bringing it to life, 1 million miles away. On Christmas Day, 2021, the James Webb Space Telescope was launched aboard an Ariane 5 rocket from French Guiana. As it ascended into the sky, it carried the hopes and fears of an entire scientific community. For the next 30 days, as it journeyed towards its final orbit, it had to perform a sequence of deployments more complex and risky than anything ever attempted. There would be 344 potential single-point failures, individual steps that, if they went wrong, could doom the entire $10 billion mission. And it all had to happen automatically, flawlessly, far beyond the reach of any human repair mission. It was a month of unbearable tension. We watched as the spacecraft first deployed its solar array, then its communications antenna. Then came the most harrowing part, the unfurling of the giant sunshield. Pallets unfolded, covers were released, and booms extended, slowly pulling the 5 delicate layers of kapton into their final, taut, kite-like shape. For days, The world held its breath as the system worked perfectly. After the shield was in place, the golden eye itself began to awaken. The secondary mirror extended out on a long tripod, and then the primary mirror's two side wings, each containing 3 hexagonal segments, folded forward and locked into place, completing the iconic shape of the Great Mirror. The telescope was sent to a very special place in space, a point of gravitational stability known as the second Lagrange point. This point, commonly called L2, lies about 1.5 million kilometers from Earth, directly away from the Sunday. Here, the gravitational pulls of the Sun and the Earth balance in such a way that the telescope can orbit the Sun in lockstep with our planet. This unique location allows it to keep its back and its sunshield constantly pointed towards the Sun, Earth, and Moon at all times, ensuring that its sensitive optics remain permanently in shadow and perpetually cold. It is from this lonely, frigid outpost that the James Webb Space Telescope began its work. It was from here that this machine, this human-made marvel of gold and beryllium, turned its gaze towards a tiny, unassuming red dot and saw, across the unfathomable expanse of time and space, the shadow of an impossible monster. The magnificent golden eye of the James Webb Space Telescope, shielded and cooled in its lonely orbit, possesses a power to see farther and fainter than any instrument before it. Yet, even for this unparalleled machine, the object at the heart of the red dot presented a formidable challenge. It lies at the very precipice of the observable universe, an object so distant that its light has been diluted and thinned by a journey of 13 billion years. The photons arriving at Webb's mirror are ancient, few, and far between. By all rights, even to Webb, this object should have been little more than an indistinct smudge, its internal dynamics and true nature hopelessly blurred by the immensity of the gulf that separates us. The fact that we could discern spinning gas clouds, that we could calculate a precise mass, that we could perform an autopsy on this cosmic ghost, suggests that humanity's ingenuity was given a helping hand. The universe, in a moment of extraordinary coincidence, provided us with a tool of its own, a natural telescope forged not from glass and gold, but from the very structure of space-time itself. To understand this cosmic gift, we must travel back in time, not billions of years, but just over 1 century, to the mind of a single man who would forever change our perception of reality. For more than 200 years before him, the universe was ruled by Isaac Newton's vision of gravity. It was a simple, elegant force, an invisible tether that reached across space, pulling objects toward one another. An apple falls from a tree, the moon orbits the earth, and the planets orbit the sun, all bound by this universal, instantaneous pull. This was the clockwork universe, predictable and orderly. But in the early 20th century, a young patent clerk named Albert Einstein began to question this foundation. He was troubled by the idea of an instantaneous force acting across the void. His thoughts led him to a conclusion so radical it would tear down the Newtonian universe and replace it with something far stranger and more wonderful. In his theory of general relativity, Einstein proposed that gravity was not a force at all. It was, he argued, a consequence of the shape of the universe itself. He imagined that space and time were not separate, static concepts, but were woven together into a single four-dimensional fabric, space-time. He then made a revolutionary claim. The presence of mass and energy warps this fabric, curving it and denting it. The analogy he gave us is one we still use today. Picture a flat, stretched rubber sheet. This represents the fabric of space-time. If you place a bowling ball in the center of this sheet, it will create a deep depression, a curve in the fabric. If you then roll a small marble nearby, it will not travel in a straight line. Instead, it will follow the curve created by the bowling ball, spiraling inward. The marble is not being pulled by the bowling ball with some mysterious force. It is simply following the straightest possible path through a curved space. This, Einstein declared, is gravity. The Earth is not being pulled by the Sun. It is following the immense curve in space-time created by the Sun's mass. This idea was breathtaking in its elegance and its implications, and it made a number of very specific, testable predictions. One of the most profound was about the behavior of light. If massive objects curve space-time, then everything that travels through space-time, including light, must follow these curves. This was a direct contradiction of the long-held belief that light always travels in a perfectly straight line. According to Einstein, the path of a light ray from a distant star would actually bend as it passed by a massive object like our Sunday. For years, this remained a purely theoretical prediction. Then, in the year 1919, the British astronomer Arthur Eddington led expeditions to Brazil and the island of Principe to observe a total solar eclipse. The plan was simple but brilliant. During the brief moments of totality, when the sun's blinding disk was blotted out by the moon, they would photograph the field of stars immediately surrounding it. They would then compare these photographs to others of the same star field taken months earlier when the sun was in a different part of the sky. If Einstein was wrong, the positions of the stars would be identical, but if he was right, the gravity of the sun would have bent the starlight passing near it, causing the stars to appear slightly shifted from their true positions. As the eclipse swept across the globe, Eddington and his teams captured their images. Months later, after painstaking analysis, the results were announced to a stunned world. The positions of the stars had indeed shifted, and by the precise amount that Albert Einstein's equations had predicted, it was a triumphant confirmation of general relativity, and the moment that catapulted Einstein to global fame. The universe was not a simple clockwork machine. It was a dynamic, curved, and flexible entity. Gravity bends light. This discovery, momentous as it was just the beginning. Einstein and his contemporaries soon realized that if the gravity of a single star could bend light by a small, measurable amount, then the gravity of something far more massive, like an entire galaxy, would have a much more dramatic effect. A galaxy, a vast collection of billions of stars, gas, dust, and enigmatic dark matter, creates a truly enormous depression in the fabric of space-time. If such a galaxy were to lie directly between us and a more distant object, it could act as a lens. Just as a glass lens in a magnifying glass or a telescope bends and focuses light to create a larger, brighter image, this gravitational lens would bend the light rays from the background source, magnifying it and making it appear brighter to an observer on Earth. Einstein himself worked out the mathematics for this phenomenon, but he concluded with a note of pessimism, believing that the chance of a perfect alignment between two stars was so small that we would likely never witness it. What Einstein, in his characteristic modesty, failed to anticipate was the power of future telescopes and the sheer scale of the cosmos. The universe is filled not just with stars, but with colossal clusters of galaxies. These are the largest gravitationally bound structures in the cosmos, veritable cities of hundreds or even thousands of galaxies, all swirling within a massive halo of dark matter. The total mass of a galaxy cluster can be quadrillions of times the mass of our Sun, creating a gravitational well so profound that it warps space-time on an epic scale. These clusters are the universe's great telescopes, nature's own optical instruments, When one of them happens to align perfectly with a distant background source, the effects are not subtle, they are spectacular. And this is precisely the cosmic coincidence that allowed us to unveil the secret of the red dot. By an almost miraculous stroke of celestial fortune, sitting in the vast expanse between Earth and the ancient object QSO-1, is a massive galaxy cluster. It is positioned at just the right distance to act as a perfect, strong gravitational lens. This cluster's immense gravity caught the faint, ancient light from the primordial black hole, light that would have otherwise passed us by or been too faint to analyze. It bent the light, focused it, and amplified it by a factor of 10 or more, transforming a barely detectable smudge into something the James Webb Space Telescope could analyze in stunning detail. Without this fortunate alignment, without nature providing us with this cosmic magnifying glass, the monster would have remained hidden forever, its existence never known. But a gravitational lens does more than just make distant objects brighter. It also distorts them, often creating multiple images of the same background source. Light from the distant object can travel along different paths around the lensing cluster, arriving at our telescope as several distinct points or arcs of light. Astronomers call this configuration a cosmic horseshoe or an Einstein cross, and it represents one of the most beautiful and informative phenomena in the cosmos. Each of these images shows the ancient black hole from a slightly different angle, and because the light paths are of different lengths, at a slightly different time, this provides an unprecedented three-dimensional view of the object, allowing astronomers to map its structure and behavior in ways that would be utterly impossible otherwise. This natural telescope, predicted in the mind of one man a century ago, became our window into the universe's darkest secrets, our tool for seeing the impossible made manifest. It was through this warped, magnified, and multiplied light that the true, terrifying nature of the object in the red dot was finally brought into focus. The light had arrived. After a journey of 13 billion years, it was captured by a golden mirror, its faint message amplified by the gravity of an entire galaxy cluster. But the arrival of this light was not an answer. It was the beginning of an interrogation. The photons gathered by the James Webb Space Telescope were the primary evidence in a cosmic mystery, clues from a scene so ancient that the universe itself was the only witness. This was not a case that could be solved with simple observation. To understand what lurked within the red dot, astronomers had to become cosmic detectives, performing a forensic analysis on the very fabric of this ancient light. They had to conduct an autopsy on a ghost. Their principal tool for this investigation was the spectrometer, an instrument of profound analytical power. While a telescope's mirror creates an image, a spectrometer takes the light from that image and dissects it. It acts like a celestial prism, but with far greater precision, splitting the incoming light into its constituent wavelengths, spreading it out into a rainbow of colors called a spectrum. Within this spectrum lies a hidden code, a series of dark and bright lines that contain a wealth of information. Every element in the universe, from the hydrogen forged in the Big Bang to the oxygen created in the heart of a star, absorbs and emits light only at specific, characteristic frequencies. These frequencies appear as lines in the spectrum, a unique, unforgeable barcode that reveals the chemical composition, temperature, density, and motion of the source. The light from the red dot was now on the examination table, its spectral barcode ready to be read. The first piece of evidence to emerge from this analysis was the chemical fingerprint of the environment surrounding the central object. The spectral lines were stark and simple. They showed a composition almost entirely of hydrogen and helium, the two lightest and most primordial elements, created in the first few minutes after the Big Bang itself. The telltale lines of heavier elements, the carbon, oxygen, and iron that astronomers collectively call metals, were conspicuously faint, almost entirely absent. This was a crucial clue. In the modern universe, the interstellar medium is rich with these heavier elements, the accumulated ash of billions of generations of stars that have lived, forged new elements in their nuclear furnaces, and died, seeding space with their enriched remains. The pristine, metal-poor environment around the red dot told a different story. It was a story of cosmic youth, an environment that had experienced minimal stellar processing. Very few stars had lived and died in this region to pollute the gas with the products of their existence. This single piece of evidence immediately put conventional theories in jeopardy. If a supermassive black hole grows by consuming the stars and gas of a host galaxy over eons, its surroundings should bear the chemical scars of that long history of star formation. But this object's environment was clean, ancient, and undisturbed. It was as if a giant had appeared in the middle of a pristine, untouched landscape, leaving no footprints to indicate how it had arrived. The ghost, it seemed, had no past. With the chemical context established, the detectives turned their attention to the dynamics of the scene. They needed to measure the motion within the red dot, and for this, they employed one of the most fundamental principles of physics, the Doppler effect. We experience this phenomenon in our everyday lives. The pitch of an ambulance siren sounds higher as it races towards us, and then drops to a lower pitch as it speeds away. This change occurs because the sound waves are compressed as the source approaches, shortening their wavelength and raising the pitch, and then stretched as the source recedes, lengthening the wavelength and lowering the pitch. Light, being a wave, behaves in precisely the same way. Light from an object moving towards us is compressed to shorter, bluer wavelengths, a blue shift. Light from an object moving away is stretched to longer, redder wavelengths, a redshift. By examining the spectral lines of hydrogen from the gas clouds within the red dot, astronomers could see this principle in dramatic action. The light coming from one side of the object was consistently blue shifted, while the light from the opposite side was consistently red shifted. This was the unmistakable, unambiguous signature of rotation. The object was spinning, with one side turning towards Earth and the other side turning away. But it was the degree of these shifts that was so alarming. The shifts were enormous, indicating speeds of a magnitude that was difficult to process. Furthermore, the spectral lines themselves were not the sharp, narrow lines one would expect from an orderly, sedate rotation. They were smeared out, broadened into thick bands. This spectral broadening was a direct measurement of the sheer violence of the motion. Within the spinning clouds, some gas was moving towards us at its maximum speed, some was moving away at its maximum speed, and a whole range of speeds existed in between. Each of these different velocities produced its own slight Doppler shift, and the combination of all these shifts blended together, smearing the hydrogen line across a wide range of frequencies. The width of this spectral smear was a direct readout of the system's internal velocity, and the velocity it revealed was breathtaking, thousands of miles every single second. Now, the investigation could move to its final, conclusive stage. Armed with the velocities of the gas at different points, the team could construct the single most important piece of evidence, a rotation curve. This process is grounded in the elegant and unyielding laws of gravity, first laid down by Johannes Kepler and later perfected by Isaac Newton. The speed at which an object orbits a central mass depends on only two things: the mass of that central object and the object's distance from it. An object farther away will orbit more slowly, while an object closer in must move much faster to avoid falling in. By measuring the rotational velocity of the gas clouds at various distances from the center of the red dot, astronomers could plot these points on a graph. This graph, the rotation curve, is the smoking gun of cosmic forensics. Different types of central objects produce entirely different rotation curves. If the mass were distributed throughout a large cluster of stars, the velocities would increase slowly towards the center. But the rotation curve of the red dot told a different story. The velocities of the gas were already incredibly high at the farthest measurable distances, and then rose with breathtaking speed as they approached the center, a characteristic curve that could only be produced by a single, unimaginably massive object concentrated into a tiny, point-like region of space. The evidence ruled out a star cluster with mathematical certainty. The ghost at the heart of the mystery was not a crowd. It was a singularity. With the rotation curve plotted, the final calculation was a matter of applying the fundamental laws of gravity. The curve was unambiguous. The velocities were confirmed. There was no room left for doubt or alternative interpretations. The mass required to hold this system together, to generate this precise rotation curve, was 50 million times the mass of our Sunday. The autopsy was complete. Through a meticulous process of deduction decoding the chemical barcode, measuring the Doppler shifts, and plotting the rotation curve, the team had pieced together a definitive portrait of their ghost. It was real. It was ancient. And it was a monster. The investigation that began with a faint stream of ancient photons had culminated in a verdict that would shake the foundations of cosmology. The red dot was not a galaxy. It was a throne, and on it sat a king of impossible proportions, ruling over a kingdom that had yet to be born. The forensic investigation was complete. The evidence, carried across 13 billion years of expanding space and focused by a lens of pure gravity, had been analyzed. The verdict was in. The ghost at the dawn of time was real. Its mass calculated, its violent motion measured. But in the grand pursuit of knowledge, a conclusion of this magnitude is never an end. It is an accusation. It is a challenge thrown down before the entire edifice of what we believe to be true. The discovery of the impossible object within the red dot was the moment that observation declared war on theory. It placed our most cherished and successful story of the universe, the standard model of cosmology, on trial. And the evidence against it was damning. For decades, we have told ourselves a magnificent story about how the universe came to be. It is a story that begins with a singular, fiery moment, the Big Bang, and unfolds over billions of years in an elegant, hierarchical dance. It is a story of gradual assembly, where small things coalesce to form larger things. Gravity pulls together tiny fluctuations in the primordial soup, forming the first, small halos of dark matter. Gas cools within these halos, giving birth to the first stars. These stars live and die, seeding the cosmos with new elements. Small collections of stars merge to become the first dwarf galaxies. These dwarf galaxies, in turn, collide and combine over cosmic eons, building up the grand spiral and elliptical galaxies we see today. It is a beautiful, orderly narrative, a bottom-up construction of cosmic structure that has been supported by countless observations and sophisticated computer simulations. This story is our textbook understanding of the universe. And now we must present the evidence that suggests this story, in its current form, is fundamentally, irrefutably broken. Let us lay out the articles of impossibility, the charges against our cosmic creation myth, with the object QS01 as the prosecution's star witness. The first and most grievous charge is the crime against time. Our established narrative has a very specific and rigid timeline for the creation of giants like the one inside the red dot. The process is understood to be majestically, unavoidably slow. The seeds of these supermassive black holes, according to the most widely accepted theory, are the remnants of the very first stars, the so-called population 3 stars. These were behemoths, hundreds of times more massive than our sun, that burned through their fuel with incredible ferocity in just a few million years. When they died, they collapsed under their own immense gravity to form the first light-seed black holes, objects weighing perhaps 100 times the mass of our Sunday. These seeds were the starting point. From there, the only way to grow into a supermassive monster was through a long, arduous process of accumulation that stretched over billions of years. This growth occurs in 2 primary ways. The first is accretion, the process of pulling in and consuming surrounding gas and dust. But this is not a simple cosmic feast. A black hole is a messy eater. As matter spirals inward, it forms a superheated accretion disk, a maelstrom of friction and radiation that shines with the light of 1 trillion stars. And this very radiation creates a problem. It exerts an outward pressure, a wind of pure light that pushes back against the infalling material. This creates a fundamental speed limit on growth, a cosmic throttle known as the Eddington limit. If a black hole tries to consume matter too quickly, the radiation from its meal becomes so intense that it literally blows its own food supply away, starving itself. This is not a theoretical nicety. It is a hard physical barrier that governs how fast any object in the universe can grow by accretion. The second method of growth is through mergers, the collision and combination with other black holes. This is a more dramatic but far rarer process, dependent on the chaotic and infrequent dance of galactic collisions. This, then, is the official story of growth, a slow, patient journey from a 100 solar mass seed, feeding at a rate strictly limited by its own radiation, occasionally punctuated by a merger event. It is a process that requires the vast timescales of cosmic history to achieve the masses we observe in the modern universe. And this is where the timeline of QS01 becomes a physical impossibility. We are observing an object of 50 million solar masses at a cosmic age of just 700 million years. Let us consider the math. Even if we grant the most optimistic assumptions that a 100 solar mass seed black hole formed at the very instant the first stars could exist, and that it began feeding at the absolute maximum rate allowed by physics, the Eddington limit, every single second of every single minute of every single day for the entire 700 million years without ever stopping or being interrupted, it could, at most, have grown to a few million solar masses. To reach 50 million solar masses requires a growth rate that does not just exceed the Eddington limit, but shatters it. It would require the black hole to have consumed matter with a voracity that our understanding of physics declares to be impossible. The timeline does not just fail to add up, it is short by a factor of 10 or more. The object simply did not have enough time to be born and grow according to the rules we have written. The second charge is the crime against proportionality. In our story of the cosmos, supermassive black holes and their host galaxies are not separate entities. They are partners in a grand, symbiotic evolution across thousands of observed galaxies. From small spirals to giant ellipticals, we have found a remarkably consistent and fundamental relationship. The mass of the central supermassive black hole is almost always a tiny, predictable fraction, about 0.1% of the mass of its galaxy's central bulge of stars. This tight correlation, known as the Megorian relation, is a cornerstone of galaxy evolution theory. It suggests a process of coevolution, a feedback loop where the galaxy provides the fuel for the black hole to grow, And the black hole's energetic output, in turn, regulates the rate of star formation in the galaxy. They grow together, their sizes linked in a delicate cosmic dance that maintains this constant ratio across eons. The black hole is the heart, but the galaxy is the body, and the body is always vastly larger than the heart. QSO-1 violates this sacred proportionality in the most extreme way imaginable. The forensic analysis of its light reveals a bizarre and inverted reality. The object appears essentially naked. The surrounding population of stars is so insignificant, its collective light so faint, that it is almost undetectable. Conservative estimates suggest that the black hole outweighs its stellar environment by a factor of at least 2 to 1. More extreme calculations suggest the ratio could be hundreds or even thousands to 1. This is not a simple deviation from the rule. It is a complete demolition of it. The heart is not just larger than the body. The heart is the body. It is a situation so absurd it has no parallel anywhere in the known universe. It is a captain whose very existence dwarfs the ship he is meant to command. The concept of co-evolution, of a symbiotic partnership, is rendered meaningless here. This object did not grow with a galaxy. It exists in place of one. This profound imbalance suggests a formation mechanism entirely alien to the gradual, dance-like process we have so carefully documented in our cosmic neighborhood. The third and final charge is the crime against heritage. Our story of the universe is a story of enrichment, of cosmic genealogy. The Big Bang created only hydrogen, helium, and a trace of lithium. Every other element on the periodic table, every atom of carbon in our bodies, every atom of oxygen we breathe, every atom of iron in our blood, was forged in the nuclear heart of a star. When massive stars die in supernova explosions, they cast these newly created heavy elements out into space. Each subsequent generation of stars is born from these enriched clouds, and they, in turn, create even heavier elements. The metallicity of any region of space, its abundance of elements heavier than hydrogen and helium, is its birth certificate. It is a chemical record of its ancestry, a testament to the number of stellar generations that lived and died to pave the way for its existence. A supermassive black hole, born from the seeds of dead stars and fed by the gas of a mature galaxy, should exist in an environment rich with this cosmic heritage. It should be surrounded by gas that has been processed and reprocessed through countless stellar furnaces. But the spectral barcode of QSO-1, as we have seen, reveals an environment of shocking purity. The gas is a pristine, metal-poor relic of the early universe, almost unchanged since the moments after the Big Bang. This lack of a chemical heritage is the final nail in the coffin of the conventional story. It corroborates the other two charges with chilling finality. The object could not have grown by consuming a galaxy over billions of years, because the chemical evidence proves there was no significant, mature galaxy there to consume. It could not have been built from the seeds of countless dead stars, because the environment shows no trace of their elemental ghosts. The evidence rests. The beautiful, orderly story of our universe's formation lies shattered by a single, inexplicable fact. The question is no longer whether our theories are incomplete. The question is, where do we even begin to build a new one? The journey to find the answer to this cosmic crisis is still ahead, with the most incredible and audacious theories about to be revealed. If you don't want to miss a single clue in this ongoing cosmic investigation, make sure you subscribe and turn on notifications to continue this journey of discovery with us. When the established story of the cosmos shatters, when the textbooks are proven wrong by a single, defiant point of light, where does one turn? When the maps of the known universe lead to an impossible land, The only path forward is to discard the maps and reconsider the very nature of creation itself. The crisis presented by the 50 million solar mass monster is so fundamental that no simple adjustment to our theories will suffice. We cannot simply tweak the parameters of galactic evolution or slightly increase the speed limit of black hole growth. The evidence demands a revolution. It forces us to seek answers not in the familiar processes of the stellar age, but in an epoch far more ancient and profoundly alien. To solve the riddle of a monster born in the wrong era, we must journey back to a time before eras existed, before stars or galaxies, before the atoms that make up our world had even formed. We must return to the crucible of the first moments of the Big Bang. Let us imagine a time when time itself had barely begun. In the first fraction of the first second of its existence, the universe was a realm that defies all human intuition. It was not a place of empty space dotted with objects, but a scalding, featureless inferno of pure energy, a seething quantum foam compressed into a volume smaller than a single atom. The four fundamental forces of nature, gravity, electromagnetism, and the strong and weak nuclear forces were likely merged into a single, unified superforce. The very concepts of space, time, and matter as we know them were fluid and ill-defined. This was the universe at its most extreme, a state of such immense energy and density that it is governed not by the classical, predictable physics of our everyday world, but by the strange, probabilistic, and ghostly laws of quantum mechanics. It is in this primordial chaos, in this quantum genesis, that a new and radical creation story for our monster may be found. Our story begins with an event known as cosmic inflation. According to this leading theory, in the first 10 to the power of -36 seconds after the Big Bang, the universe underwent a period of exponential, faster-than-light expansion. It was an expansion of such unimaginable violence that it took a region of space smaller than a proton and stretched it to a size larger than a galaxy in a fleeting instant. This inflationary epoch is crucial to our understanding of the modern cosmos. It smoothed out the universe, making it incredibly uniform on the largest scales, yet it also planted the seeds for all the structures we see today. How did it do this? Through the magic of quantum physics. The infant universe, even in its near-perfect uniformity, was subject to the fundamental uncertainty of the quantum world. The energy field that drove inflation was not perfectly smooth. It fizzed with tiny, random, microscopic fluctuations. These were fleeting jitters in the energy density, virtual particles popping in and out of existence, a constant, unavoidable quantum hum. Under normal circumstances, these fluctuations would have remained microscopic and insignificant. But the hyper-expansion of inflation acted as a cosmic amplifier. It grabbed these subatomic jitters and stretched them to enormous astrophysical scales. Tiny, fleeting variations in energy density became vast regions of space that were slightly denser or slightly less dense than their surroundings. When inflation ended, the universe was left imprinted with this pattern of slight irregularities. These were the primordial seeds, the blueprints from which all future structure, every star, every galaxy, every cluster of galaxies would eventually grow under the patient, relentless pull of gravity over billions of years. But what if some of these seeds were different? What if, by pure statistical chance, some of these random quantum fluctuations were not just slightly denser, but exceptionally denser than the average? This is the heart of a mind-bending hypothesis, an idea first explored in depth by the physicist Stephen Hawking. The theory posits that in the chaotic, energy-rich environment of the post-inflationary universe, some of these newly macroscopic, over-dense regions would have contained so much energy and matter packed into a relatively small volume that they would have been unable to resist their own gravitational pull. There was simply too much mass in too small a space. And so, in the first second of cosmic existence, these regions would have undergone a catastrophic gravitational collapse. They would not collapse to form stars or planets. The universe was still a hot soup of elementary particles, far too hot for atoms, let alone stars, to form. Instead, they would collapse past any known state of matter, crushing themselves down to an infinitesimal point of infinite density. They would collapse directly and instantaneously into black holes. These are the primordial black holes, and they represent a class of object entirely distinct from the stellar mass black holes we are familiar with. Stellar black holes are the endpoints of evolution. They are the corpses of massive stars. Primordial black holes are not made, they are born. They were never stars. They never experienced a life of nuclear fusion. They were forged directly from the raw, untamed energy of the Big Bang itself. Cosmic knots tied in the fabric of space-time at the moment of its creation. This hypothesis is not mere speculation. It is a plausible consequence of our best understanding of early universe physics, and it offers a breathtakingly elegant solution to the entire crisis presented by QS01. It takes the three articles of impossibility, the charges of time, proportionality, and heritage, and dismisses them completely. First, it solves the crime against time. The primordial black hole hypothesis bypasses the slow, gradual process of accretion and merger entirely. QS01 did not need 700 million years to grow from a small seed. It did not need to feed at impossible super-Eddingtonian rates. In this new story, the black hole could have been born with a mass of 50 million suns in the first microsecond of the universe's existence. The question of how it grew so fast becomes meaningless. It did not grow into a monster. It was born a monster, fully formed in the fires of creation. The timeline crisis evaporates. Second, it solves the crime against proportionality. The reason the black hole appears naked without a host galaxy is because it was born before galaxies had even been conceived. In this scenario, the primordial black hole would have existed for hundreds of millions of years during the cosmic dark ages, a solitary, invisible titan wandering through the primordial soup of hydrogen and helium. It was not a heart formed within a body. It was a pre-existing gravitational anchor, a massive seed that existed first. Only much later, as the universe expanded and cooled, would the patient pull of its gravity begin to gather the surrounding gas, eventually triggering the formation of the first stars and the gradual assembly of a galaxy around it. The process we are witnessing with QS01 is not the end of a galactic partnership, but the very beginning. We are seeing a galaxy in the process of being born, drawn into the gravitational embrace of a monster that was already ancient. Finally, it solves the crime against heritage. The pristine, metal-poor chemical environment is no longer a mystery, but a confirmation. The black hole did not require generations of stars to seed its formation, so there is no reason to expect their chemical ghosts to be present. The surrounding gas is pure because it is the original, unprocessed material of the Big Bang. The black hole formed first, and the gas came later. This perfectly explains the lack of heavy elements and supports the idea that we are witnessing a system in its absolute infancy. A black hole that has only just begun to interact with and influence its surroundings. If this theory is correct, it paints a picture of the early universe that is profoundly different from our previous imaginings. It suggests that the cosmic dark ages were not empty, but were populated by a hidden menagerie of these primordial monsters. ranging in size from the mass of an asteroid to masses of millions or even billions of suns. These objects would have been the gravitational scaffolding of the early cosmos, the silent architects that shaped the subsequent formation of galaxies. This idea is so powerful that some cosmologists have proposed that primordial black holes could even be the mysterious dark matter that constitutes 85% of the matter in the universe, its gravity holding galaxies together. While this remains a contentious idea, the existence of objects like QSO-1 has given it a new and tantalizing lease on life. The primordial black hole hypothesis is not without its challenges. It requires very specific, fine-tuned conditions during cosmic inflation to produce the right number and size of black holes. For now, it remains a beautiful and compelling theory, a potential creation myth for a new cosmology. And the 50 million solar mass monster, once an impossible paradox, now stands as its most powerful and persuasive piece of evidence. The allure of a monster born directly from the quantum fire of the Big Bang is powerful. A story of cosmic genesis that feels almost mythological. It is an elegant and complete solution to the crisis facing cosmology. But science is a realm of competing ideas, a landscape where even the most beautiful theory must contend with other possibilities. What if the answer to the impossible red dot is not so primordial? What if the universe did not need to conjure a monster from the ghostly foam of its first second of existence? What if, instead, there exists a different path? A loophole in the established laws of star formation that allows nature to build a giant from scratch? To explore this alternative, we must move our investigation forward in time, from the first instant of creation to a period a few 100 million years later, and search for a very specific kind of cosmic laboratory, a place with the perfect set of ingredients and conditions to follow a different, far stranger recipe for creation. To appreciate this forbidden recipe, we must first understand the standard, universal recipe for making stars, a process that has been unfolding across the cosmos for over 13 billion years. It begins with a vast, cold cloud of gas, primarily hydrogen and helium, drifting within the invisible gravitational scaffolding of a dark matter halo. For this cloud to transform into a constellation of stars, a critical process must occur. It must be able to cool down. A gas cloud is a chaotic swarm of particles, and their random motion creates an outward pressure that fights against the inward pull of gravity. For gravity to win, for the cloud to collapse, it must be able to shed this internal energy, to radiate its heat away into the cold of space. In the modern universe, this cooling process is greatly assisted by the presence of heavy elements, the cosmic metals forged in previous generations of stars. Atoms of carbon and oxygen are particularly effective coolants, acting like tiny radiators that allow the gas to cool efficiently. But in the pristine environment of the early universe, these elements were exceedingly rare. The only significant coolant available was molecular hydrogen, a fragile molecule formed when two hydrogen atoms bond together. As the primordial gas cloud begins to collapse under its own gravity, it forms this molecular hydrogen, which then radiates away heat, allowing the collapse to continue. But this cooling process has a crucial consequence. It leads to fragmentation. The cloud does not collapse into a single, monolithic object. Instead, as it cools and becomes denser, it breaks apart into thousands of smaller, turbulent, clumpy regions. Each of these individual clumps continues to collapse independently, its core growing hotter and denser, until, one by one, they ignite the fires of nuclear fusion and are born as stars. This is the standard outcome, the universal recipe. A giant gas cloud inevitably begets a sprawling cluster of many stars. It does not, under any normal circumstances, create a single, solitary monster. But what if we could sabotage this recipe? What if we could find a way to prevent the fragmentation, to force the entire colossal cloud to collapse as one? This is the basis of the direct collapse theory, an audacious idea that proposes a pathway to forging a supermassive black hole without ever forming a single ordinary star. It is a recipe for a monster, and it requires a set of ingredients and conditions so specific and so rare that they could likely only be found in the unique environment of the early universe. The first ingredient is a truly massive, pristine cloud of primordial gas. Not just any cloud, but one containing the mass of at least 100,000 suns, all settled within a giant halo of dark matter. And it must be chemically pure, almost entirely free of the heavy elements that would act as efficient coolants. The second, and most crucial, ingredient is the strategic removal of the standard coolant. The recipe demands that we prevent the cloud from cooling via molecular hydrogen. We must find a way to destroy these fragile molecules as soon as they form, thereby preventing the cloud from fragmenting into a mere star cluster. The key to this sabotage is a catalyst, a third ingredient, an intense, nearby source of ultraviolet radiation. The recipe therefore requires a specific cosmic neighborhood. Our pristine, massive gas cloud cannot be in isolation. It must be located relatively close to a neighboring protogalaxy, one that has already begun to form its first generation of massive, brilliant blue stars. The fierce ultraviolet light from these neighboring stars acts as a cosmic blowtorch, flooding our pristine cloud with high-energy photons. This radiation is perfectly tuned to break apart the delicate bonds of molecular hydrogen, destroying the cloud's only effective means of cooling. With its primary cooling mechanism disabled, the cloud is now in a precarious state. Gravity is still pulling it inward, but it can no longer cool and fragment. The result is a slow, hot, monolithic collapse. The entire 100,000 solar mass cloud begins to fall inward as a single, coherent entity. Matter funnels towards the center at a staggering rate, hundreds of times faster than in the standard star formation process. As this material piles up in the core, it does not immediately form a black hole. Instead, theorists predict it creates a bizarre, transient object known as a supermassive star, or a quasi-star. This would be a bloated, incandescent behemoth, perhaps 1 billion miles across, containing the mass of tens of thousands of suns. It would shine with the light of 1 billion suns, but its power would come not from nuclear fusion in its core, but from the sheer, raw energy of its own ongoing gravitational collapse. This colossal, unstable star is the penultimate step in our recipe. It cannot sustain itself for long. The pressures and temperatures in its core would be beyond anything seen in a normal star. After a very short and violent life, perhaps only a few million years, the heart of the quasi-star would inevitably succumb to its own immense weight. The core would collapse catastrophically, unopposed, crushing itself down past the point of no return and forming a black hole. But because the entire supermassive star was the progenitor, this would not be a light seed of 100 solar masses. This process would create a heavy seed black hole, an object with an initial mass of anywhere from 10,000 to 100,000 times that of our Sunday. This forbidden recipe, this direct collapse pathway, provides a second, compelling solution to the crisis of QS01. It presents an alternative narrative to the primordial black hole hypothesis, a story not of a monster being born in the Big Bang, but of one being made through a rare and extraordinary astrophysical process. Let us see how this suspect holds up against the charges. First, it addresses the crime against time. While this theory does not entirely eliminate the need for growth, It provides an enormous head start, starting from a seed of 100,000 solar masses, instead of a mere 100, makes the task of reaching 50 million solar masses in the available time far more plausible. It transforms the impossible marathon of the light seed model into a challenging but potentially achievable sprint of accretion. The heavy seed is already a giant, needing only to grow by a factor of a few hundred, not a few 100,000. Second, the direct collapse model beautifully explains the crimes of proportionality and heritage. The recipe itself requires the very conditions we observe around QS01. It can only work in a pristine, metal-poor environment, which explains the lack of a chemical heritage. Furthermore, the entire process is geared towards preventing the formation of a large population of stars, and instead channeling all of the available matter into a single, central object. This naturally creates a system where the central black hole dominates its surroundings, where the heart is vastly out of proportion to the barely existent body. The nakedness of the black hole is not a mystery in this model. It is a direct and necessary consequence of its own formation. So we are left with two prime suspects, two powerful and compelling stories that could explain the existence of the impossible monster. One tells of a giant born from the pure quantum physics of the universe's first second. The other tells of a giant made through a precise and rare set of cosmic circumstances a few 100 million years later. The primordial black hole versus the direct collapse black hole. The born versus the made. This is now one of the most active and exciting debates in modern cosmology. Scientists are actively hunting for evidence that could distinguish between these two scenarios. They are searching the skies for the unique, faint spectral signature of a dying quasi-star. The smoking gun that would prove the direct collapse recipe is real. They are analyzing the distribution and masses of the growing population of little red dots to see if they fit the statistical predictions of one model better than the other. It is entirely possible that the universe is not limited to a single pathway. Perhaps the early cosmos was a place of wild creativity, a laboratory where giants were forged through multiple, extraordinary means. The red dot may not be evidence of a single, secret history, but of a time when the universe was young and full of impossible possibilities. We have pursued two extraordinary pathways to creation, two epic tales of how a monster might be forged in the crucible of the early universe. One story speaks of a giant born directly from the quantum fabric of the Big Bang, a primordial entity predating the stars. The other tells of a giant made, constructed through a rare and precise cosmic recipe that subverted the normal laws of star formation. Whether born or made, we have constructed a plausible history for our ghost, a potential solution to the crisis of its impossible existence. But the mystery of the object in the red dot is not confined to its origins. Just as we begin to feel a sense of understanding, the object presents us with another, deeper puzzle. It is a paradox not of its past, but of its present, a mystery of its behavior. It is the riddle of the silent scream. To understand this riddle, we must first understand the nature of a black hole's voice. An isolated black hole, floating alone in a perfect vacuum, is the most silent thing in the universe. It is a perfect darkness, a perfect quiet. But the monsters we are discussing are not isolated. The evidence from the James Webb Space Telescope, the broad hydrogen lines, the signature of furiously spinning gas, tells us unequivocally that they are feeding. And a feeding black hole is the very opposite of silent. It is, in fact, the source of the most violent, energetic, and luminous roar in the entire cosmos. This roar originates in what is arguably nature's most efficient and brutal engine, the accretion disk. Matter does not simply fall into a black hole like a stone into a well. Due to the conservation of angular momentum, the infalling gas, dust, and shredded stars are forced into a spiraling, flattened vortex around the black hole's equator. This is the accretion disk. It is not a gentle whirlpool. It is a maelstrom of unimaginable violence. As countless tons of matter are dragged closer to the event horizon, the gravitational shear and immense friction heat the material to temperatures that dwarf the core of any star. We are not talking about thousands or even hundreds of thousands of degrees. The inner regions of an accretion disk are heated to millions or even tens of millions of degrees Celsius. At these temperatures, atoms are torn apart, their electrons stripped away, creating a superheated plasma that glows with an intensity that can outshine entire galaxies. But this is not a gentle, golden glow like that of a star. The extreme temperatures involved mean that this engine of accretion radiates primarily in the highest energy wavelengths of the electromagnetic spectrum. It should be a colossal beacon of ultraviolet radiation, and, even more intensely, X-rays. This is not a theoretical prediction. It is a fundamental, observed reality. The brightest, continuously shining objects in the universe are not stars or even supernovae. They are quasars, an abbreviation for quasi-stellar radio sources, which we now know are the brilliant accretion disks surrounding actively feeding supermassive black holes in the distant universe. Their X-ray and ultraviolet emission is their defining characteristic. It is their voice, their cosmic roar, a scream of such intensity it can be heard across billions of light years. This is the established, textbook behavior of a feeding black hole. It is the signature we have come to expect, the cosmic rule. Knowing this, astronomers approached the little red dots with a clear expectation. The James Webb Space Telescope had seen their infrared signature, the evidence of rapidly moving gas that proved they were active. The next logical step was to observe them with telescopes designed to see their high-energy scream. They turned humanity's great X-ray observatories, like the Chandra X-ray Observatory, towards these ancient phantoms, fully expecting to be blinded by a torrent of X-rays. They were looking for the roar of a 50 million solar mass monster devouring its meal. What they found was an eerie, baffling, and profound silence. Where there should have been a brilliant cosmic lighthouse, there was mostly darkness. Some of these objects, including the one in our red dot, showed no detectable X-ray emission at all. Others emitted only a faint, pathetic whisper, a signal 100 or even 1,000 times weaker than what any existing model would predict for a black hole of that size. Feeding at that apparent rate, the paradox was absolute and deeply unsettling. The evidence in the infrared spectrum was the equivalent of seeing a colossal buzzsaw spinning at thousands of revolutions per minute, its teeth a furious blur. But the evidence in the X-ray spectrum was the equivalent of hearing no engine, no roar, no sound at all. It was the signature of a silent, ghostly engine. How can a black hole be screaming with motion in one form of light, yet be utterly silent in another? Like any good ghost story, the first step is to seek a rational explanation, to try and debunk the phantom. The most obvious and mundane possibility is that the monster is, in fact, screaming at the top of its lungs. But its voice is being muffled. Perhaps, the theory went, the black hole is shrouded in a thick cocoon of gas and dust, a cosmic veil that absorbs the high-energy ultraviolet and X-ray photons before they can escape into space. This would be a simple and elegant explanation. However, the evidence from the scene of the crime does not support it. The spectral analysis of the red dot's environment revealed it to be chemically pristine and metal poor. Such environments are not known for producing the large quantities of cosmic dust needed to create such a thick, absorbent shroud. Furthermore, a dust cloud absorbing that much energy would itself heat up and re-radiate that energy at longer infrared wavelengths, creating a specific thermal signature. The James Webb Space Telescope is perfectly designed to see such a signature, and it is simply not there. The theory of a muffled scream does not fit the facts. The second rational explanation involves a trick of geometry. Perhaps we are simply viewing the accretion disk from a very unlucky or lucky angle. Some models of active galactic nuclei include a thick, donut-shaped torus of dusty gas orbiting outside the main accretion disk. If we happen to be looking at the system perfectly edge-on, this torus could block our direct view of the central engine, hiding the X-ray and ultraviolet glare, while still allowing us to see the more spread-out, infrared-emitting gas clouds above and below it. This is a plausible scenario for any single object. However, as Webb and other telescopes discover more and more of these little red dots, this explanation becomes statistically untenable. We are finding hundreds of these X-ray quiet objects. The odds that every single one of them, scattered randomly across the sky, would be perfectly aligned edge-on to our line of sight are astronomically small. The silence does not seem to be an accident of our perspective. It appears to be a fundamental and intrinsic property of these ancient beasts. Having ruled out the mundane, we are forced to confront the strange. The ghost is real, and it is genuinely quiet. This means our understanding of how such ghosts behave must be wrong. We must consider more exotic possibilities, new chapters in the physics of how black holes consume matter. One leading idea is that these primordial black holes feed in a fundamentally different manner than their modern counterparts. The standard, well-studied model of a hot, thin accretion disk that radiates violently in X-rays may not be the only way to eat. Some theorists propose a mode of cold accretion, where streams of cold, pristine, primordial gas can flow directly towards the black hole's event horizon in a more orderly, streamlined fashion. These cosmic rivers of gas might not experience the same degree of internal friction and shock heating, allowing the black hole to gain mass without forming the hyperluminous, X-ray emitting disk. It would be a quieter, more efficient, and stealthier mode of feeding. Another possibility is that the extreme feeding rates themselves change the physics of the disk. At near Eddington rates of consumption, the radiation pressure within the disk can become so intense that it puffs the disk up, transforming it from a thin, dense pancake into a thick, bloated, toroidal structure. This puffy accretion disk might be so optically thick that the high-energy X-rays generated in its very core are trapped, unable to escape. They would be absorbed and re-emitted multiple times within the disk, their energy downgraded until they finally emerge as lower-energy ultraviolet or optical light, explaining the absence of the expected X-ray scream. A final, haunting possibility is that we are witnessing a sleeping giant, one that is only occasionally stirring. Perhaps the period of its most violent growth is already over, and it has consumed the majority of the easily available fuel in its immediate vicinity. A mostly dormant, slumbering black hole would produce minimal radiation. The broad hydrogen lines, the evidence of motion that we do see, might not be the signature of a steady, ongoing meal. Instead, they could be the flicker of a final snack, a lone gas cloud that has wandered too close and is being tidally disrupted, its gas briefly flaring up as it is consumed. This would be enough to create a temporary stir in the infrared that Webb can see, but not enough to fully reignite the furious, high-energy furnace in the core. Each of these possibilities would represent a monumental shift in our understanding of black hole astrophysics. The silent scream is more than just a curiosity. It is a clue that the physics of accretion, the very process by which these monsters grow and interact with their environment, may have been fundamentally different in the pristine, chaotic conditions of the early universe. The ghost remains. It is an entity that grows without a roar, a predator that stalks the cosmic dawn in an unnerving silence. Its quiet nature is another layer of profound strangeness, a puzzle not just of its origin, but of its very soul. The eerie silence of the primordial monster is a deeply unsettling mystery, a phantom whisper from an engine that should be roaring. But its true significance may not lie in the object itself, but in what its mere existence represents. In the world of science, as in the complex web of human affairs, there is rarely such a thing as an isolated crisis. An anomaly that appears in one area is often a symptom of a deeper, more systemic problem, a crack in the very foundation of our understanding. The discovery of the object in the red dot was not just the discovery of a new celestial species. It was the pulling of a loose thread that now threatens to unravel the entire tapestry of modern cosmology. We are only now beginning to see the connections, the shocking and profound ways in which this one impossible fact cascades outwards, shaking the foundations of other, seemingly unrelated cosmic mysteries. This is the story of the domino effect. The first and most immediate domino to fall is our cherished story of the cosmic family tree, the formation of galaxies. For decades, the established narrative has been one of a clear and orderly hierarchy. It is a bottom-up story. It begins with the invisible, ghostly halos of dark matter, which act as the gravitational basins of the cosmos. Primordial gas is drawn into these basins, where it cools and collapses to form the first small stars and dwarf galaxies. These fledgling galaxies then embark on a billions of years long journey of growth through mergers and collisions, gradually assembling themselves into the grand, mature galaxies we see today. In this story, the supermassive black hole is a late addition. It is a child of the galaxy, a seed that forms in the dense galactic center and grows in tandem with its parent, a passive consequence of the larger process of galactic evolution. The galaxy is the architect. The black hole is merely a feature of the final design. QSO-1 takes a sledgehammer to this orderly picture. Its existence as a naked, 50 million solar mass titan in a universe too young to have built a proper house for it strongly suggests that the entire hierarchy is inverted. It is the prime piece of evidence for a revolutionary top-down model of cosmic structure formation. In this new and radical story, the black holes come first. The primordial monsters, whether born as quantum seeds in the Big Bang or forged in the crucible of a direct collapse, are the true progenitors. They are the massive gravitational anchors that exist before the galaxy. They are the architects, not the afterthoughts. Imagine these giants dotting the dark, starless expanse of the early universe. They are the true centers of power, their immense gravity warping space-time around them, creating deep wells into which the primordial gas of the cosmos would inevitably be drawn. The galaxy is not the parent giving birth to a black hole. The galaxy is the consequence. A vast, slow-motion accretion of matter, a cosmic weather system forming around a pre-existing center of immense gravity. This is not a minor revision. This is a coup d'état in the cosmic order. It reframes the role of black holes from passive passengers in galactic evolution to the active drivers of it. Their immense energy output would regulate the birth of the first stars. Their gravity would dictate the shape and size of the forming galaxies. The entire cosmic web, The large-scale structure of the universe might have been shaped by the influence of these pre-existing behemoths. The first domino has fallen, and it has completely rewritten the story of our own galactic origins. But the chain reaction does not stop there. As this first domino strikes the next, it forces us to confront one of the most profound and persistent enigmas in all of science, the mystery of dark matter. For nearly a century, we have known that the universe is haunted by a form of invisible matter. We can see its gravitational effects everywhere we look. It is the unseen mass that keeps the stars in our galaxy from flying apart. It is the invisible scaffolding that holds entire clusters of galaxies together. It constitutes a staggering 85% of all matter in the universe, yet we have absolutely no idea what it is. The leading hypothesis for decades has been that dark matter consists of some new, exotic, undiscovered subatomic particle, a weakly interacting massive particle, or WIMP. We have built colossal, ultra-sensitive detectors in deep underground laboratories all over the world, attempting to catch a fleeting glimpse of one of these particles as it passes through the Earth. After decades of searching, we have found nothing. The trail has gone cold. The primordial black hole hypothesis, resurrected from theoretical obscurity by the evidence of QSO-1, now presents itself as a bold and audacious new suspect in this decades-old cold case. What if the reason we cannot find a dark matter particle is because there is no particle to find? What if dark matter is not made of undiscovered particles at all? What if it is simply a vast, uncounted population of primordial black holes? This theory suggests that the Big Bang did not just create the potential for a few giant monsters like QSO-1, but a whole spectrum of them, ranging in size from the mass of a small asteroid to the mass of many thousands of suns. These smaller, non-feeding primordial black holes would be completely invisible, interacting with the universe only through their collective gravity. They would perfectly mimic the effects we attribute to dark matter. The missing mass holding our galaxy together would not be a cloud of exotic particles, but the combined gravity of trillions of ancient, unseen black holes, the forgotten debris of creation itself. This is a paradigm shift. QSO-1 becomes a crucial piece of circumstantial evidence. Its existence proves that the universe could make massive black holes primordially. If it could make a 50 million solar mass version, it is entirely plausible that the same physics could have created an enormous number of smaller ones as well. The mystery of the impossible monster and the mystery of the missing dark matter suddenly become two sides of the same coin. The second domino falls, not only rewriting the history of galaxies, but also potentially solving the greatest mystery of what the universe is actually made of. The cascade continues, as the implications of this new picture of the early universe reach out to shake a third, and perhaps the most critical, pillar of modern cosmology, our measurement of the expansion of the universe itself. For the past decade, cosmology has been in a state of quiet crisis, a predicament known as the Hubble tension. The crisis is this. We have two independent and highly precise methods for measuring the Hubble constant, the rate at which our universe is expanding today, and they give us two different answers. The first method looks at the local universe. By observing a special type of exploding star called a Type 1, a supernova in nearby galaxies, we can calculate their distance and speed with great accuracy, giving us a direct measurement of the current expansion rate. The second method looks at the early universe. By studying the cosmic microwave background, the faint afterglow of the Big Bang, we can create a near-perfect model of the infant universe. Using this model, our standard model of cosmology, we can then predict how the universe should have evolved over 13.8 billion years and what its expansion rate ought to be today. For a long time, The results from these two methods were close enough that the difference could be chalked up to measurement error. But as our telescopes and techniques have improved, the error bars have shrunk, and the discrepancy has refused to disappear. In fact, it has become a significant 5 sigma contradiction. This is not a trivial disagreement. It is a fundamental breakdown in our understanding of the universe. It suggests that either our measurements of the local universe are wrong, our measurements of the early universe are wrong, or, and this is the most profound possibility, the model we are using to connect the two is wrong. This is where the third domino falls. The existence of monsters like QSO-1 is a direct assault on the validity of that connecting model. Our prediction for the Hubble constant from the early universe relies completely on the assumption that our standard model of cosmology is a correct description of cosmic history. This model assumes a relatively smooth, orderly, bottom-up formation of structure. But QSO-1 and its brethren are irrefutable evidence that the early universe was far more violent, more chaotic, and more top-heavy than our model allows. The formation of so many massive objects so early in cosmic history would have dramatically altered the universe's evolution. These giants would have heated the surrounding gas, stirred up the primordial plasma, and accelerated the clustering of dark matter in ways our simple models do not account for. If our history of the early universe is wrong, then our prediction for the present day, derived from that history, is also likely to be wrong. The Hubble tension might not be a conflict between two measurements, but a conflict between one measurement and one flawed prediction. The impossible monster in the red dot is a clue that the cosmic rulebook we have been using to understand our universe's life story is missing a critical chapter on the influence of primordial giants. By forcing us to rewrite that early history to account for a more violent and accelerated youth, it may provide the very solution needed to resolve the greatest and most vexing crisis in modern cosmology. The conspiracy is revealed. A single point of light has connected the story of galaxy formation, the enigma of dark matter, and the crisis of cosmic expansion. These are not separate problems to be solved in isolation. They are all symptoms of a single underlying truth. Our picture of the early universe has been profoundly incomplete. QSO-1 was the first domino to fall, and in its wake, we are witnessing the spectacular, cascading collapse of old ideas, making way for a completely new, far stranger, and more deeply interconnected picture of our cosmos. We have followed the chain reaction, the cascade of falling dominoes, from the mystery of a single red dot to the very foundations of our cosmic model. The crises are now entwined, the questions interconnected. It has become clear that light, the ancient messenger that has guided us on this incredible journey, the photon-based evidence that has built our cases and exposed our ignorance, may no longer be enough to illuminate the deepest secrets of the primordial age. The universe, we now realize, has another story to tell. A history written not in the language of electromagnetic radiation, but in the very fabric of space-time itself. To truly understand the birth of monsters, we must now learn to listen. We must learn to hear the symphony of gravity. For all of its power, light has a fundamental limitation. The entire story we have pieced together, the infrared glow seen by the James Webb Space Telescope, the pristine chemical barcode read by its spectrometers, the eerie absence of X-rays is a story told by photons. It is a tale woven from a single thread, and that thread can only take us back so far. There is a wall in cosmic history, a barrier beyond which light cannot pass. For the first 380,000 years after the Big Bang, the universe was not the transparent, star-dusted void we know today. It was a hot, dense, opaque fog of ionized plasma. In this primordial state, photons of light were trapped, unable to travel more than a short distance before being scattered by a free electron or proton. This era is a cosmic dark age in the most literal sense, a period shrouded from the view of any telescope. No matter how powerful, the events that may hold the ultimate answers to our crisis, the physics of cosmic inflation, the potential birth of primordial black holes in the first second, are forever hidden behind this impenetrable wall of plasma. Light cannot show us our own creation. But what if there was another messenger? A messenger so fundamental that it is not impeded by a fog of plasma. A messenger that can travel unimpeded from the very instant of the Big Bang directly to us today. This was the final, and perhaps most profound, prediction to emerge from Albert Einstein's theory of general relativity. He realized that if space-time is a flexible, dynamic fabric, then the most violent and energetic events in the cosmos should create ripples in it, disturbances that propagate outwards at the speed of light. These are gravitational waves. They are not waves of energy traveling through space. They are waves of space itself. Imagine space-time as the surface of a still pond. A calm, quiet event will leave it undisturbed. But a catastrophic event, two massive black holes spiraling into one another and merging, would be like dropping two heavy stones into the pond. The collision would send out ripples, waves of pure gravitational energy that stretch and squeeze the fabric of space-time as they travel. These waves are the ghostliest and most subtle phenomena in the universe. They pass through planets, stars, and entire galaxies as if they were not there. Their interaction with matter almost non-existent. For nearly a century, they remained a purely theoretical prediction. Their existence inferred, but never directly observed. They were thought to be so incredibly faint by the time they reached Earth that detecting them would be impossible. But in the year 2015, humanity achieved the impossible. The Laser Interferometer Gravitational Wave Observatory, or LIGO, a pair of gigantic L-shaped detectors in the United States, announced the first ever direct detection of a gravitational wave. The signal was unimaginably faint, a distortion in space-time that stretched and squeezed the 4-kilometer-long arms of the detector by a distance less than 1/10,000th the width of a proton. But it was real. The signal, when converted into sound, was a brief, rising chirp, the unmistakable sound of two stellar mass black holes, each about 30 times the mass of our Sun, finally merging in a distant galaxy over 1 billion years ago. In that moment, humanity gained a new sense. For the first time in our history, we were no longer just looking at the universe, we were listening to it. This newfound sense is the key to unlocking the final secrets of the primordial monsters. The ground-based detectors like LIGO are magnificent achievements, but they are tuned to hear only a specific part of the cosmic orchestra. The rapid, violent merger of stellar mass black holes produces high-frequency gravitational waves, the equivalent of the high-pitched notes of a piccolo or a violin in the cosmic symphony. The events we truly need to hear the birth cries of the early universe are of a completely different character. The merger of two supermassive black holes, each weighing millions or tens of millions of suns, is not a rapid chirp. It is a slow, majestic, and incredibly powerful process that can take years to complete. The gravitational waves they produce are of a very low frequency, a deep, resonant bass note that carries across the universe. Our ground-based detectors are fundamentally deaf to these ultra-low frequencies. The constant seismic and atmospheric noise of the Earth itself drowns them out. To hear the music of the giants, we must build an observatory in the perfect silence of space. This is the purpose of the Laser Interferometer Space Antenna, or LISA, a future mission of breathtaking ambition that will act as a galactic-scale ear. LISA will not be a single spacecraft, but a constellation of 3, flying in a perfect triangular formation, millions of kilometers on a side, trailing the Earth in its orbit around the Sunday. Each spacecraft will be in a constant state of perfect freefall, shielded from the solar wind and any other disturbance. They will be connected by laser beams, forming an interferometer of unprecedented size. As a low-frequency gravitational wave from a distant supermassive black hole merger washes through our solar system, it will minutely stretch and squeeze the distance between these spacecraft. By measuring these infinitesimal changes in the laser paths, LISA will be able to detect and reconstruct the wave. It will be able to hear the slow, inexorable inspiral of primordial giants in the dawn of time. When LISA begins its mission, it will usher in a new era of discovery. It will not just detect a handful of events, it will open a new, continuous window onto the cosmic symphony. We will hear the constant, overlapping background hum of countless compact objects merging throughout the universe's history. We will be able to pinpoint the specific merger events of 10,000 solar mass heavy seeds in the infant universe, providing the definitive, smoking gun evidence that could prove or disprove the direct collapse model. We might hear the gravitational wave signature left over from the epoch of cosmic inflation itself, a direct echo of the first moment of creation. If the universe is indeed filled with a population of primordial black holes, LISA will hear the symphony of their ancient mergers, mapping their distribution and providing the final evidence in the case of dark matter. LISA will hear the events that light can never show us. It will be our ear to the Big Bang. We find ourselves, then, at a profound turning point in our cosmic journey. For millennia, we have been a species defined by sight, looking up at the patterns of the stars, building telescopes to extend our vision beyond the horizon of our own eyes. Now, we stand on the cusp of becoming a species that can listen, that can perceive the universe through a sense that is as fundamental as space and time itself. The discovery of the impossible object in the red dot has been a lesson in humility. It has shattered our neat and tidy stories and forced us to confront a cosmos far more violent, chaotic, and creative than we had ever dared to imagine. It has revealed a universe where the greatest of giants were born first, in an era of darkness, through processes that defy our conventional understanding of physics. But this monster has also been a guidepost. In exposing the limitations of our old ideas, it has pointed the way towards a new and deeper level of inquiry. It has forced us to seek new tools, to imagine new ways of observing, to strive to hear the story that light cannot tell. Our connection to these events is not merely academic. The iron in our blood, the carbon in our cells, all were forged in the hearts of stars that lived and died in galaxies whose very formation was likely governed by the silent, invisible influence of these primordial behemoths. We are, in a very real and physical sense, the children of a universe shaped by monsters. We are the legacy of their violent creation. And we are, as far as we know, the only part of that universe capable of looking back, of piecing together the clues, and of finally beginning to understand our own profound and extraordinary origin story. The silent ghost in the red dot has shown us the way, forcing us to question everything and pointing us toward a future where we will not only see the cosmos, but will listen to its deepest, oldest, and most powerful music, the symphony of gravity itself. Our dialogue with the universe has only just begun, and the questions it raises are profound. What are your thoughts on humanity's place in this grand symphony. We would love to read your reflections in the comments section below. And if journeys of discovery like this awaken the curiosity within you, consider joining our community by subscribing for more explorations into the great unknowns.